Okay, so we're about to do section 2.4 video part 2. And what I want to do is I want to go to the 10 problems that I did on the previous example where we had practiced. I gave you 10 inequality problems that were already solved. We want to go back to those 10 problems and we graph them. But now what I want to do is go back and show you how to do the interval notation. Now, before I do that, let me just explain quickly in mathematics what the word interval means. An interval is like a time spot. It's a span of numbers. For instance, if I say I'm going to work from 8 a.m. to 3 p.m., 8-3, 8 a.m. to 3 p.m., that is an interval of numbers. It means 8, 9, 10, 11, 12, 1, 2, 3, etc. If you go to a department store and you see a rack of clothes that says these clothes are $15 to $20. That means $15 to $20. That is an interval of numbers. It is a range of numbers. If you're talking about temperature, it says the low for today is 61. The high for today is 89. 61 to 89 is a range of numbers. So that's what we mean by interval of numbers. Now, not all numbers are bounded on both ends. For instance, if I say something like the wind is going to be 7 miles per hour today or faster. That means I don't know how fast it's going to get, but I know that it's going to be at least 7 miles per hour. So sometimes an interval is not bounded on both ends, like $15 to $20. So let's go back to our very first example here. This problem right here. Now, what I want to do is I want to describe this set of numbers right here. Well, now remember, you're looking at the red, not the black. We're looking at the graph. So if I was going to describe this set of numbers, this would be the set of numbers from 4, starting at 4. Now, what does that arrow mean? It means it goes on forever. Well, remember, we call that in mathematics infinity. So the way I would do this interval notation would be 4, comma, and that's the infinity symbol right there. You will find that in the... if you click, when you're entering your answers, if you click on that word more at the bottom of the screen in MyLabs Plus, it will open up a template of symbols. That's where that infinity symbol is. Now, I need to show something a little more. I need to show that we can use the 4. So the way I will do that is put a bracket on the 4. You will never bracket the infinity. Never. So we will always put a parenthesis here. So this is just another way of saying that right there. This is what we call interval notation. This is interval notation. Now, when you go to do the next one, interval notation is almost the exact same way. It's 4 to infinity, but it's parentheses on both. Now, if you do the next one, it's going to be from -3 to infinity. So Mr. Rainer, is it safe then to say that if that graph starts at a number and goes to the right, it'll always go to infinity? Yes. All right, now, let's look at this next one. Here was the next one that we did. Make sure I haven't cut it off on you. This was the problem that we did, the fourth problem we did. X is less than or equal to 3. Now, whenever you're describing an interval, you always describe an interval of numbers from the smallest to the biggest set of numbers in that interval. For instance, when you go into a department store, they don't say this. The clothes on this rack range anywhere from $15 to $10. They don't say from $15 to $10. They say what? from $10 to $15. So an interval of numbers is never given from the biggest number to the smallest number. It's always from the smallest number to the biggest number. Here's why that's important. If you will notice the numbers that's on this graph, what's in red, 3, 2, 1, 0, etc. 3 is no longer the smallest number on this graph. It's the biggest. So when you're doing an interval, you go from smallest to biggest. This is the biggest number on the red graph because it's furthest to the right. So that 3 now will not go in front of the comma. It will go behind the comma with a bracket. So if the graph goes to the left forever, what do you think that implies? You say, well, infinity. You are partially correct. It is actually negative infinity. So you say, okay, Mr. Ryan, I think I've got it. So if the graph goes to the right, you have an infinity on the right side of the comma. Correct. If an arrow goes to the left, it's negative infinity, and it always goes on the left side of the comma. And you never put a bracket on infinity or negative infinity. So this next one, x is less than negative 5. Because that's going to the left, I would put negative infinity, comma, and then negative 5. So that's all of the numbers from negative infinity up to negative 5. Okay, and then the last two. This one right here, x is less than 2. Going to the left, that means negative infinity, 2. This one's going to the right, so that means the infinity goes on the right side of the comma, so that'd be negative 4, comma, infinity. So, what you should be able to do then at this point is if I give you any solved inequality, you ought to be able to do two things. You should be able to graph it on a number line, and you should be able to give me the interval notation. Now, we still haven't talked about how to get down to this part yet. I've only shown you what to do once you get here. I've shown you how to do this, and I've shown you how to do the interval notation. But I haven't showed you how to take the problem down to this yet. Now, pay attention to the instructions because sometimes he will ask you to graph and do the interval notation. Sometimes he will just say, give me the interval notation. So if it's greater thans, infinities on the right. Less thans, negative infinities on the left. All right. So that's how you graph, that's how you do interval notation. All right, now the big part of this section is this. Remember to put this problem back up that I put in the last video. How do we take this problem right here? How do we take this one and get down to here? Let me just, don't copy this down because we're going to do this problem in a minute. But if you'll look at this problem, look starting right here. Now look right here. What we did was we were starting right here and we did the graph and the interval. So I need to teach you how to go from here to here. That's what we call solving the inequality. All right. I don't give you a lot of verbal notes, but I am going to give you a verbal note here that you need to write down. So take this note down. And I will quote it slowly, but make sure you write this down. Here's the note. When solving an inequality, remember you can pause at any time. When solving an inequality, we use the same process that we use with linear equations, with one exception. Here's the exception. if we divide both sides by a negative number, in the last step of the solving process, we must flip the inequality symbol. We must flip the inequality symbol. And again, you go back and replay that and you pause it as much as you need to so that you can write that down. All right, let me explain basically what that means. You know how when we solved equations, we got the x's on one side, numbers on the other? We're going to do the same thing here. What are we going to do if it's got grouping symbols? We're going to use distributive properties. What are we going to do if it's got fractions? We're going to multiply through and get rid of fractions. The only difference will be is when you get down to that very last step. Remember, if you have a number in front of that x, like 8x equal 24, how do we get rid of that number that is in front of x? We get rid of it by dividing. When you divide in that last step, if you divide by a negative number, divide by a negative number, you're going to have to flip the inequality symbol around. Now, there's reasons for that. I'm not going to go into all the details on that right now so that I can get straight to the problems. But that's mainly what you need to know there. Now, do remember when we go to work these, remember, keep in the back of your mind what I said a while ago. I will never on these get my x's on the right, ever. In inequalities, I always get the x's on the left. Okay, so the instructions to this next group of problems will be this. Solve, graph, and give the interval notation. Solve, graph, and give the interval notation. Solve, graph, and give the interval notation. Okay, so here we go. Let's look at this problem right here. All right, 2x plus 1 greater than negative 7. So what I'm going to do is I'm going to do this just like this was an equal sign. So you're going to get the x's on one side, you're going to get the numbers on the other. So subtract 1 from both sides. By now you should be accustomed to doing that. When I do, I get 2x greater than negative 8. How do we get rid of the number in front of x? By dividing. Whatever you do to one side, you have to do to the other. And so when I do, I get x is greater than negative 4. Now you said, oh, wait a minute, Mr. Ryan, I thought you said if you divide, you have to flip this symbol. No, I said if you divide by a negative, you have to flip the symbol. So that is the solution to that problem. That means that this problem right here, up here, has millions of answers. It's anything negative 4 and bigger. Any number you picked would make that up there be true. All right, how do we graph that? Greater than negative 4 is going to go to the right of negative 4 with the parentheses. We've already done that, so I'm not going to, you spend a lot of time there. And then there's the interval notation. Okay, let's go to the next one. Don't worry that this one's highlighted. That won't matter to you at this point. Okay, 3x plus 11 greater than or equal to 5x plus 3. All right, this is that two-step problem. If this were an equal, you'd subtract 11 from both sides and subtract 5x from both sides. But get the x's on the left. So if I do it in one step, we've talked about this, that's what it would look like. Now, we did a whole bunch of these in 2.1. Now, 3x minus 5x is negative 2x, greater than or equal to negative 8. But now I have to divide by the coefficient of x, which is negative 2. And when I divide by that negative 2, I have to flip that symbol around. So now, the answer is all the numbers less than or equal to 4. So what would the graph of that look like? All of the numbers 4 and to the left. So it'll be a bracket on the 4 going backwards. Since it's going to the left, that's negative infinity, and negative infinities always goes on the left side of the comma. So the number will go on the right side of the comma and a bracket because of the equal to. All right, let's do 2 more to close out this section and this video. This is the one that I've been flashing up to you several times. So we've got 5 minus 3 times 2x minus 1 less than x minus 3x minus 4. Remember again, you can pause the video at any point if I get ahead of you. All right. Now what I want to do is, remember I always want to do everything I can on both sides first. Well, I have grouping symbols. How do we get rid of grouping symbols? By distributing. But when you distribute, remember you're not multiplying by 3, you're multiplying by negative 3 times both of these. Same thing over here. To get rid of these grouping symbols, you're not multiplying by 1, you're multiplying negative 1 times both of these. All right, when I distribute on the left, bring the 5 down. Negative 3 times 2 is negative 6x. Negative 3 times negative 1 is plus 3. Now the right side, bring the x down. Negative 1 times 3 is negative 3x. And then negative 1 times negative 4 is plus 4. Now I'm still not cleaning up the 2 sides. On the left side, bring down the negative 6x. But 5 plus 3 is plus 8. On the right side, x minus 3x is negative 2x. And then bring down the plus 4. Now you're back to that same 2-step process again, where you're getting the x's on one side, getting the numbers on the other. So I'm going to subtract 8 from both sides and add 2x to both sides. If you do it in one step, this is what it looks like. So we're down to negative 4x less than negative 4. Divide by the coefficient of x. Notice again, I got the x on the left side, because if I get it on the right, I'm more apt to graph it backwards. So divide both sides by negative 4. But since I'm dividing by negative 4, I have to flip the symbol. Now, how do I represent all the numbers greater than 1? It's all of the numbers to the right of 1. Parentheses because there's no equal to. Since this graph is going to the right, that means infinity, and infinity always goes on the right side of the comma. Never put a bracket on the infinity. And it started at 1, parentheses, because there's a parentheses there. Okay, last example from this section. And you say, now wait a minute. This one, let me make sure you can see it all. Yeah. You said this one has fractions in it. So what are we going to do with this one? We're going to do the same thing that we did in the last section. To get rid of a problem that has fractions in it, you can get rid of fractions in inequalities just like you do equations. Find a big enough number and multiply every term on both sides. Every term on both sides. All right, so what are we multiplying by? Dividing 3, dividing 2. So we got to multiply by 6. So I'm going to put a 6 here, 6 here. Don't forget to put a 6 right there also. So I'm going to put a 6 by every one of those. Now, sorry about that. Now, do you remember the famous 3 words? Cross, cancel, first. So take your pencil, 3 and 6 and put a 2. 2 and 6 and put a 3. And then there's no canceling over here. So mark that out. Now, after you mark it out, this is what yours should look like. It should look like that after you mark it out. You don't have to rewrite it, but when you mark yours out, this is what you should have. Now, what's 2 times 2x? 4x. But be careful when you distribute right here, you're distributing with a negative 3. So it's negative 3 times x, negative 3 times negative 3, which is plus 9. Now 4x minus 3x is x. Subtract 9 from both sides to get x is less than negative 3. And this doesn't have to end up being a whole number. Probably if it's not a whole number, he won't ask you to graph it. He will ask you to do the interval notation though. There's your graph. Everything to the left, less, a negative 3, and interval notation. So let's suppose this had been 3/5. This would be negative infinity to negative 3/5. So a lot of times if it's a fraction, he may not ask you to graph it. But anyway. Okay, that concludes section 2.4. Next section 2.5, we're going to continue looking at inequalities, but we're going to look at a special kind of inequalities that has a special name in section 2.5. This concludes section 2.4, part 2.